Welcome to Chapter 3 on ratios and proportions. Before I can get into the nitty-gritty and the down and dirty, we're going to have to take a moment and do some basic graphing, because we will do graphing in this chapter because we're talking about proportional relationships and they have particular looking graphs. So let's digress for a lesson and go back over basic graphing. Let's start off with what we label. We have the x-axis, which goes which direction? Yes, it goes left to right. If we were going to write the more technical term, what is lines called that go left to right? They would be called horizontal. The horizon goes left to right. And then the y-axis goes up and down, and that is called vertical, which at the end of the school year I like to add to my spelling list because it knocks a lot of kids out, this word. Vertical, vertical. Okay. All right. The x-axis is the independent axis. Ain't nobody gonna tell me what to do. Independent. Cannot be affected by others. Affected with an A. Extent of my English skills there. Not to be confused with an effect. This is affect, the verb. The dependent axis does change other things. It is affected. It is affected by the independent variable. Coordinates is the fancy word for the what? Coordinates look like this. They have an X and a Y. They always go in alphabetical order if I was going to use different letters. This is a coordinate. We plot the coordinates. You guys probably used to call them points. You use this all the time. What are your coordinates? Coming to find you. This is your location, your coordinates. Okay, so we got our graph here. And again, you plot the points X and then Y. So when I have the point 1, 2, it's positive 1 on the X and positive 2 on the Y. This section of the graph is called quadrant 1. There's the point 2, 1. 2 on the X, 1 on the Y, and it's positive. When I make the X negative, like negative 3, 2, we're in quadrant 2. If I was to make negative 1, negative 3, I would be in quadrant 3. And then a positive X, 3, and a negative Y, negative 3, would end up with quadrant 4. So we are labeling this in counterclockwise order. Counter, meaning the prefix for against the clock. This is called counterclockwise. So think about it. If you have to label a graph where it says go to quadrant 2, you're doing it counterclockwise. 1, 2, 3, 4. These are Roman numerals. 1, 2, 3, 4. Okay? Let's describe how to plot negative 1, 2. Now remember, this is alphabetical. X before Y. So on the x-axis, if it's negative, you are going to go left, 1 space, and then this is a positive 2, so you're going to go up 2 spaces, because this is the left to right, this is the up to down. Probably going to get some announcements soon, and I'll have to pause. Graphs you see a lot are graphs of speed. A graph should always have a title. So there's my title, speed. We should label our Y and X axis. This is my dependent axis. This is my independent axis. Time is almost always on the x-axis. If you can't understand if it's dependent or independent and you have to guess, you're going to guess that time goes on the x-axis. Okay, so if we're doing speed, how do you get your speed? Well, your speed is what dependent on your time? It is your distance. How far you can go and how much time will tell you your speed. Distance depends on how long you've been going. Okay, so I'm going to write down what I said one more time. Majority of problems have time on the x-axis. Time is on the x. Almost all the time, time is on the x. So let's try a problem. So I asked myself, when can time depend on something else? How long I have to do something? What could that depend on? It could depend on the size of the job, maybe. It could depend on if you've committed a lot of crimes. So if I commit a whole bunch of crimes, I'm going to spend a whole bunch more time in jail. So I'm going to label this jail. And that was a couple of the things I could think of where time might actually be on the y-axis. Make sure you are writing everything down that I'm writing. So if you have to pause the video, you pause the video. You've got time, pause video. Okay? So now I'm going to go through a word problem. It says find the pattern. You will like that part. You guys like patterns and you put stuff in the table. We're going to label the graph. We're going to plot the points. We're going to draw a line. We're going to write an equation. So I have a stepdaughter, Jasmine. She loves to run. It's her thing. You ever meet somebody that loves to run? I mean, these are people who will go out in a blizzard and still run. And I'm like, I'm just going to watch TV. Have fun with that. So Jasmine ran 3 miles in 21 minutes. The next day, she ran a much longer race of 6 miles, and she did it in 42 minutes. If she's a running machine, like a robot, and doesn't ever get tired, how long would it take her to run 7.5 miles? So you are not to just start answering my question. We're going to start with what's the independent and what's the dependent. So look back in here and find the variables. What depends on what? How far she runs, which is the miles, depends on her minutes. Remember what I said. Time is almost on the x-axis all the time. Time, x-axis. So let's draw these in. You are going to be using either Cami, which is wonderfully erasable and so much neater than the normal work I used to get. The miles depend on the minutes. Y depends on X. Minutes are independent. Miles are dependent. We're talking about Jasmine's run, so I'm going to put a title. People want to know, what am I looking at? I'm looking at a graph that I'm going to make about Jasmine's run. Okay, now let's put this stuff we put over here back in the table. Independent is the minutes. Dependent is the miles. And I'm going to skip this spot for a reason you will find out. And then I'm going to put the first piece of information I have. I have how many minutes? 21 minutes. She ran 3 miles. What else did they tell me? They told me, let's look for it, 6 miles, 42 minutes. 6 in the miles, 42 in the minutes. So let's start with what's the start? The start of the race. How much time has gone by at the start of the race? 0. She's standing at the starting line. And at the starting line, how much distance has she traveled? 0. Okay? Not every single table we do is going to have 0, 0 in it. But if I'm running a race, that makes sense. So I'm going to teach you a trick. I am sure you could figure out this pattern. Well, let's do the pattern. So here I'm counting by what? 3s. Every 3 miles is 21 more minutes, so another 3 miles. This is called work, writing this stuff down over here. So this is 9, right? And then add another 3 and I get 12. And every additional 3 miles is going to be another additional 21 minutes. So this was 21. Now, you probably don't need to do it for this table, but I want to show you a trick. Check this out. Check this out. Do it with me. Grab your calculator. I'm going to put in 0 in my calculator because it's my starting number, and I'm going to press enter. And then I'm going to create a formula. I'm just going to press plus 21. See how it says ANS? This is a cool trick to know, guys. So do it with me. ANS means take my last answer and add 21. I press enter. I get 21, correct? Now all I have to do now that I have this wonderful formula in is to press enter again, and it will do the last answer plus 21, which is 42. And I press enter. The next one's 63. So over here I'm going to put 63. I'm going to press enter again, and it's going to tell me 84, and I'm going to put it in here. Nice little trick. You might use it from time to time. So now I'm going to plot the points. My minutes go from like 0 to 84. That is the range. This is the minimum. This is the maximum. Max minus min gives me the range. So that's 84. And then my range for miles is 0 to 12. So that's 12 minutes. So here's my miles. I have to get to 12. So let's do what probably most people do and see if we can count by ones. So right here is definitely going to be 0. 1, 2, 3, 4, 5, 6, 7, 8. I only got to 8. I really wanted to get to 12. So what should we count by instead? 2s sound good. Now remember, you want to make your graph as big as possible. The whole point of graphing something and making a picture of information is so that it's easy to read. If you make things small, it's not easy to read. So let's count by 2s. Put the number right in the middle of the line. 2, 4, 6, 8. Isn't this wonderful and great? It's a little low stress, easy peasy, lemon squeezy. I like to rhyme. It is a crime. That is why I'm DJ M. Rob. Okay, I labeled it. It is important that you do not skip numbers, as in count by different amounts. Every line on my graph is worth 2. I do not just take whatever I see here and plop it on a line, because it won't always make every space an equal amount, okay? Most common student error is when these numbers skip around, students just take it, write it, take it and write it. You can't do that. You must make sure that every space is counting by the same number. And that is why graphing will end up being difficult, because some of us just want to see it and write it, and sometimes you need to redo it. So over here, I'm not just going to take these numbers and plop them on here. I could, but because everything counted by 21s, that sounds funny, but it would make my graph crowded. So I have to go from 0 to 84. I'm not going to count by 21. How many lines do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any good ideas? What do we count by? If I count by 2s, I'll only get to 16. I want to count by 3s. Still not going to make it. 4s, 5s, not going to make it. How about we count by 10s? Does that make sense? 10. Now that was really weird what I just did. See that? I didn't label every line. But I want to ask you, did I count by the same amount for each space? Is this space worth 10? Is this space worth another 10? It certainly is. So I just want to emphasize, if for some reason this got too crowded and I wanted to skip a line label, skip a line label, skip a line label, I could. It would look like this. I would do 20, 40, 60, 80, 100. And it would actually look a little neater than what I just did. But I would still be counting by 10s. If I did 20, 40, 60, 80 to 100, I'd still have every space as 10. Okay, if you don't understand, then call me over in class so I can go over it with you. So both of these had 0 at the beginning, which is great. It's less confusing that way. So let's plot some points. I got 0, 0, that's easy peasy. Is this point right here. That has a special name, by the way. The point 0, 0 is called the origin on a graph. I think I'll write it down. It's probably going to come up a few times this chapter. Okay, and then we're going to graph 21 minutes, 3 miles. 21, well, we're going to estimate. It's pretty close to 20, and then 3 is easier. It's halfway between the 2 and the 4. Okay, so we're going to plot that point. 42, 6. Now, you can't copy the graph from this video. You have to do that part on your own. If you try to take this picture off the screen and put it on your paper, it's going to lose its spot by the time it gets to your paper. So you have to legit do this yourself. So 42 is close to 40, and then 6 is exactly on the line. 63 is a little further from 60, almost halfway, almost half of a half. We're going to go to 9, which remember is halfway between the 8 and the 10. 84 is almost halfway between 80 and 90, and then directly on the line for 12. Should this continue, if she was a running machine, it would point forever. I mean, that's not truthful though. She can't run forever. You got to stop to eat at some point, etc. And I do connect the dots because is she running 30 seconds into the race? Yeah. Is she running when it's 5 minutes into the race? Yeah. So we're going to connect these because there's an infinite amount of dots on this line. She's always running. So it's continuous. It's a continuous line here. So I want to ask you, what is her unit rate? How many miles per minute? If she runs 3 miles in 21 minutes, what is that in miles per minute? What does this line mean? This line means divide. And it is going to come out as a decimal, isn't it? It's less than 1, isn't it? She's not running a whole mile in a minute. That would be like insane. So 3 miles, oops, I was going to press divide. No, I'll put it in as a fraction. And then this, she's running about that much of a mile in a minute. And that's kind of ugly. I'm going to change it back to a fraction. It's 1/7 of a mile in a minute. She is running 1/7 of a mile in a minute. And I get this number by always taking my dependent variable and dividing by my independent variable. For every 1 mile, it's 7 minutes. 2 miles is 14 minutes. 3 miles is 21 minutes. So what happens if I was going to write an equation, it would look like this. 1/7 times the number of minutes will tell you how far she has been. 1/7. We were going to get into this into more detail later. We're going to get into this into more detail in the next lesson. The focus of today, though, is can you fill out a table? Can you do dependent, independent, label, correct scale, counting by the right amount of numbers, label, draw your graph. Plot your points, draw your graph. Now, that is the point of the lesson. So what I want you to do is you're going to do the other side. There's one question here. You're going to do it on your own. Read it. Sometimes some of the numbers are written as words or they're implied. So you're going to have to look for the other number in this problem that is besides 6. And label it, y-axis, x-axis. Put your stuff in here. So find the pattern, complete the table, label the graph, plot the points, draw the line, see if you can write the equation. If you can't, you can check the answer key or we can go over it. And every day I throw away 6 sheets of paper. How much have I thrown away at the end of the week? Oh, it looks like I didn't answer the question on the other side. Every day. How many days? Didn't answer the question on the other side. How long does it take her to run 7.5 miles. Well, let's use the graph. 7.5. Here's 7, here's 7.5. We'll go over here till we hit the line, and then we'll go down. Well, I think I went a little crooked. It's not quite 55, so I would say somewhere around 53. This is an estimate. It's okay. 53 minutes. If I was going to do this exact, maybe you would figure out another way to do it, like 7.5 miles times 7, and you would see it's 52.5 to be exact, which is 52 minutes, and half a minute, which is 30 seconds. Is that all that important right now? No, that's not my focus right now, but in case you were wondering, if I give you the miles, which is 7.5, I would multiply it by 7 to get my minutes. It's kind of a work backwards from this. Okay, in any event, you have one practice problem to do. Do it to it. See you later.